Alright, we are doing 5-6 graphing rational functions. So, this is about graphing rational functions. And to do that, you've got to do some things. So, the first thing you want to do is you want to identify your parent function, which is y equals 1 over x. And if you put that in there, you'll get something that looks like this. This little thing, you know? And, as you can see, it doesn't touch the line here. And that is because these lines are asymptotes. And asymptotes are lines that the graph cannot touch. It's very important to know. And then, so, gotta clear this off. And, whoa there. Okay, so, that's gone, and now, so we have the parent function right here, y equals 1 over x, and our vertical asymptote is right here, because that's a vertical line. That's the asymptote. And the vertical asymptote, you can write that as x equals 0, and our horizontal asymptote, which is this line right here, kind of, yeah, that one, you can write that as y equals 0. Crazy, I know. And the domain and range is of these lines. And as you can tell by my beautifully drawn graph, they don't touch these lines. And so what you're going to want to do is, because it is continuous, you are going to make it go from, well, no. Okay, and so then the domain is going to be negative infinity to 0, and you're going to put parentheses and not little brackets, because it doesn't include the 0, and union, that's the little u, parentheses, because it doesn't touch the 0, positive infinity, and you're done with the domain, which is the x, right? Which is the x thing right here. And the range is going to be of this one right here. And so, as you can see, I will draw the lines again, because you obviously cannot see them anymore. But, so yeah, as you can kind of see, the range is of this one. And you see how these don't touch the 0 right here. And so, you're going to basically do the same thing, and it's negative infinity to 0, union 0 to infinity. What does end behavior mean? And, now you see, and now, we're going to erase everything. This may take a bit. Hold on. Alright. So, the letter equation thing for this is y equals a over x minus N, H, not N, plus the letter K, like potassium. And, so yeah. And the A right here, that controls the stretch or shrink. So, is the graph going to go wide, or is it going to go tall? Who knows? It's a mystery. Until you find out what A is, of course, then you know. And, X here is, your X. It's X, it's still there. Like, Y equals 1 over X. It's the same thing. And, your H over here determines whether it'll go left or if it'll go right. And then your K for potassium doesn't actually stand for potassium in math. What am I doing? Your K determines if it'll go up or down. And now you see there's a special thing that goes on with the H, is that if it's a negative number, it's going to go to the right. So, if it's like minus 2, is going to go to the right 2. But, plus 2 means left 2. Crazy, I know. But, let's erase everything again. Somehow. Maybe. Ah. And so we are ready to do a problem.
Okay, now we're gonna do number 1. Okay. So, let's see. This right here is your H. And then this number right here is your K.
Potassium.
Okay.
Don't forget the A.
Yeah, and this number right here will be your A. Okay. So,
And pause it really fast.
okay, so whenever you start off, let's see, this, your H, which is the positive 3, will become a negative, or,
-3.
yeah, and then your K will stay the same. So, whenever you graph it, you would go over here to -3 and up to 2. I'll do that right here. So, right here. So this will be your graph. And right here is positives. And then over here would be your negatives. And then your domain and range would be negative infinity to -3, and then it'd be
-3.
yeah, -3 to infinity, and then it'd be negative infinity to
Union.
yeah to infinity.
Woo! And that is number 1. Alright, so now we're going to do number 2. And how you're going to do number 2 is you identify everything. So, your A is 1. Your H is 5. And your K is 3. Is that a negative? Negative 3. That's a negative 3, everyone. Weird negative. Okay. But, back to the point. We have identified our thingies. And now, you can graph it. And, so expanding on what Shelby said before, you're going to flip this to a negative because this means 5 to the left because it's a positive, and positives go to the left. And so you're going to want to change that to a negative 5 because that's where you're going to land on the graph if you go backwards 5 spaces. Oh. Technical difficulties. And, so yeah, so you're gonna want to go 5 to the left. 3, 4, 5. And down 3. 1, 2, 3. Wait. 1, 2, 3, 4. Okay, here we go. And we're just gonna label that as, negative 5, 3 is that. And then our graph is going to go into these quadrants, number 1 and 3. And the pink line represents the asymptote. So I'll write it out. Asymptote. And yes, back to you, Shelby.
Okay, now to number 3. Here is our A, and our H would be negative 2, and our K is going to be positive 4. So, let's see, that would switch to a negative 4. So, 1, 2, 4, 1, 2.
And I do something real quick.
So, it would go, our graph would go like that. And then domain would be negative infinity to infinity. Or, sorry, messed up. It would be negative infinity to 4. And then it would be the U thing. And then infinity to, or 4, I'm sorry, I'm messing up, 4 to infinity. And then for our range would be negative infinity to negative 2. And then it would be negative 2 to infinity. Even though it doesn't ask for the domain and range, I thought I would put that, show you how to do that. Okay, and now we're done. Thanks.
Woo!
Bye.